All right, so here we're going to review factoring the difference of two perfect squares. And I abbreviate this DOTS, right? It stands for difference of two squares. Okay, so when you think about difference, right? Difference means we're subtracting. Now, two perfect squares, as long as the term before the subtraction sign and the term after the subtraction sign is a perfect square, we could factor this using the DOTS method. Okay, so let's do it. So how this works is you first set up two sets of parentheses. One of them gets an addition sign and the other gets a subtraction sign. It doesn't matter which one gets what. And then you take a look at the first term. Okay, we're going to take the square root of the first term. Well, the square root of 4 is 2 because 2 times 2 gives you 4. And the square root of x squared is x because x times x gives you x squared. So I'm going to put a 2x in the first spot in each parenthesis. Okay, now when we look at the second term, right, the square root of 9 is 3 because 3 times 3 gives you 9. So that's what goes in the second spot within each parenthesis. And this is it. This is written in factored form. All right, let's take a look at the next one. It says 25 minus x squared. So we have a difference, right? There's a subtraction sign. And both of these are perfect squares. So let's jump into it. We set up our two sets of parentheses. One gets an addition, and the other gets a subtraction. And the square root of the first term goes in the first spot in each parenthesis. So since the first term is 25, the square root of 25 is 5, right? 5 times 5 gives you 25. And then the square root of the second term would be x, because x times x gives you x squared. So the square root of the second term goes in the second spot within each parenthesis. Okay, and that's it. That's factored. Okay, so again, all you're doing is you're setting up two sets of parentheses. One of them gets an addition, and the other gets a subtraction. And you take the square root of the first term and put that in the first spot, and the square root of the second term and put that in the second spot. Okay, now, the third one, although when you look at this, this is a difference of perfect squares. Here's the deal. If you can factor out a greatest common factor, you're going to want to do that first. And look at this, right? 4x to the fourth and 36. Can't you divide each of these terms by 4? Okay, and we don't want to divide it. We want to pull it out. We're going to pull out the greatest common factor of 4. Now remember, when you pull out a greatest common factor, we only put one parenthesis with what we're left with. Okay, so 4 divided by 4 is 1. If you want to put a 1 here, you can, but you don't have to, because see this x to the fourth? That's going to go in this spot. That's what we're left over with. So 1x to the fourth is the same thing as x to the fourth. And then negative 36 divided by 4 is negative 9. Okay, so the first step is to pull out the greatest common factor if you can. In these two examples, we couldn't. Okay, now we're going to look in the parentheses and say, can I factor further? Well, yes, I can. This is a difference, and both of these are perfect squares. So don't forget to bring down the 4. And once you do, now we open up our two sets of parentheses. One gets an addition, and the other gets a subtraction. And the square root of x to the fourth is x squared, so that goes in the first spot in each parenthesis. And the square root of 9 is 3, so that goes in the second spot in each parenthesis. And there we have it. That is factored completely.